Welcome to page 19 of your linear packet. On this page, we're going to compare three graphs. Our I can statement states, given three graphs, I can compare the rate of change and the y-intercepts. If you look across the top of your page, you can see we've been given some notes. We have the standard form for a non-proportional linear equation, mx plus b equals y, or y equals mx plus b. We have a reminder that slope represents the rise, delta y, over the run. That's our m value, our slope. And lastly, our y-intercept, or our b value, is known as the initial start value. Let's take a look at our graphs. The directions state, find the slope, or the rate of change, and the y-intercept for each graph. Write an equation for each graph. Let's take a look at letter A. Substance temperature. We have time in hours, that's our x value, and we have the temperature that represents our y values. We know we have to write an equation, so we're going to use the form mx plus b equals y. Let's start with our b value. Our y-intercept, or our initial start value, which is located here on the y-axis. You can see the initial start temperature is 20 degrees. Please take down these notes. Now, let's get our m value, or our slope, or rate of change. It is our delta y, our rise, or our vertical change, over our delta x, which is our run value, our horizontal change. We're going to take 2 points located on the line, and we're going to darken those 2 points. Let's rise from the point furthest to the left, rise up 2 degrees, run over 1 hour. 20 to 22 means we're going up 2 degrees. 2 degrees per or over, and then our run value is 1 hour. That is our delta x per 1 hour. So 2 degrees per every 1 hour, if we divide, our m value, our slope, is 2. So we can write the equation 2 times every hour x plus an initial start temp of 20 degrees equals y. So there's our first equation, the rate of change, and the initial start value. Let's take a look at our next graph. We can see in the next graph, the line does not rise as quickly as it did in the first. The pitch of the line is not as steep. Our x is still time in hours, and our y still is temperature. And even here, our initial start value, our y-intercept, b equals still 20 degrees. But this substance does not warm up as quickly as substance A. Let's get the slope. We can see this is a good readable point, and I'm going to select that point. Pick 2 points on the line, and then let's get our slope. we need to figure out our delta y and our delta x, our rise over our run. So let's connect the 2 points. We rise up 1 degree, that's our delta y, and we run over from 0 to 3, which is 3 hours. That's our delta x. So it goes up 1 degree per every 3 hours. That is our slope, or our rate of change. And we're going to leave it in that fraction form, 1/3. So we know we're going to go mx plus b equals y. In this case, our slope, our rate of change, is 1/3 times x plus, now we still start at an initial value of 20 degrees, equals y. This is the equation for our second graph. Now let's take a look at our third graph. We can see this is the steepest line of all 3 graphs. Again, for this substance, time is on the bottom and y is up the side. We still start out at an initial value, or a y-intercept, of 20. That's the same for all 3 graphs. However, if we get our slope here, our delta y over delta x, we go up 3 degrees per every 1 hour. 3 degrees per 1 hour. So if we reduce 3 over 1, we get 3. That's our coefficient that sits in front of our x. So when we write the equation, we write 3 times x plus 20 equals y. That's the equation for the third graph. Now you're going to take each of these equations and compare. You might be comparing the rate of change for each, or the slope. You might be comparing the initial start value for each, which happens to be the same. Pause the video and answer the questions below. When you're ready to check your work, turn your video back on. Let's compare answers. We can see that the greatest rate of change occurs in graph C. It's 3 degrees per every 1 hour. The slowest rate of change is graph B, 1 degree for every 3 hours. The graph that climbs at a rate of 3 degrees per hour, again, is letter C. And the one that climbs at a rate of 2 degrees per hour, well, that's over here, graph A, 2 degrees per every 1 hour. This concludes page 19.